So far we have learned about how to design a mathematical model. Then we have learned about how to apply material on this model. Uh, First we have learned how to create a new study for Solidworks simulation. Then we have learned how to apply material as we want. Then we have learned about fixture advisors. We have learned about different type of fixtures. So we have, as we can see, we have applied the static type fixtures only. If we go right here, if we go to fixed geometry, we have only selected fixed geometry right here. We will close it. So if you want, you can rename this name of the fixture right here. So to rename this, first click on this, then a little pause, and then again click on this. Now you can rename it. We will rename it to fix mathematical model. Mathematical model fixture 1. Click enter. So the name has been renamed. As you can see, the dimensions are showing right here. We don't want them right now, so we will go on this bar right here. We will drag it down, then we will drag it a little bit more, then we will go to annotation, right click on it, and we will deselect this show feature dimensions. Okay, so the dimensions are gone now. We will drag it up. So if we zoom in right here, we can see some arrows and circles right here. So it's showing that this geometry has been fixed. So if we zoom in a little bit, we can see these figures right here are showing arrows, and they have a circular shape at the bottom of them. So what it is indicating that we have locked all the 6 geometry, the arrow meaning the transitional degree of freedom, and the circle is meaning that the rotational degree of freedom has been locked for this surface right here. So this is showing us that we have locked all 6 degrees of freedom for this surface. So if we selected any other geometry, like if we selected roller or sliders geometry, then the rotational degrees of freedom would not be fixed. So it would only show us the arrows right here. If we select roller or slider geometry, only 3 degrees of freedom will be locked, and 3 will be unleashed, and 3 will be kept open. The material has been fixed. We will use the fixed geometry for this study. So now the next step to run this study, as we can see for here, we have learned new study, applied material, simulation evaluator, and fixture advisor. Now we will learn about external loads advisor. So if we click on this and drag down the bar right here, as we can see, there are many options right here. So the first one is showing force. So what is force? So the option force, this applies a force or moment to a face, edge, or vertex in the direction defined by selected reference geometry. If you click on force, let's make this clear. If you click on force, we can see that it's showing right here the force, and then it is showing the direction, in which direction we want to apply the force. So if we want to select this direction right here, this phase right here, this surface right here, it will take this surface automatically, and it will you can see here, it is given normal right here. If we select direction, then we want to give any direction we want to. If suppose we want to give assign this edge as a direction to apply the force, then we will select this edge. it is selecting right in this direction. If we want to reverse this direction, we will drag down and we will, as you can see here, this is showing reverse direction. If we click on this, the direction will be reversed. So this is force. This is force. If we want to apply force or movement to any surface or edge, for example, if we want to deselect this surface, we will click delete, and we want to select, suppose, this surface right here. So if we click this, so it also will take this surface and it will apply a certain amount of force. Here we can see the units. So if we want to apply 5000 Newton load, we will click 5000, and so it also will apply 5000 Newton load on this surface right here. If we want to change direction, again we will drag it down and we will select reverse direction. So this is the details about force. So if we drag down this one, and here we can see torque. If we want to apply torque, we will need y-axis right in the middle of this or in the middle of the model, or anywhere we want to apply the torque. We will first need an axis. As we don't have any axis here, I can't show you the application of torque. We will learn about application of torque in the later lecture. So let's move forward and let's cross this. The next is about pressure. So pressure is normal pressure. If we want to add any kind of pressure right here, so for example, if we want to select this surface here, and we can define the amount of pressure we want to apply, and we can choose here between normal to the selected face. We can apply it to the selected face, or we can use this as a reference geometry, and then we can add another face right here. This will be a reference geometry, and the amount of force pressure we want to apply, suppose 5000, it will be applied on this surface right here, and this will be the reference surface. So normal to the selected face, we want to select this face right only. So if we want to change the direction, we will simply click change the direction right here. So this is all about pressure. If we want to analyze the pressure on the certain structure, this will be the method. So let's cross this one, and then we will again see the next one, which is gravity. So if we click on gravity, it applies linear acceleration to parts or assemblies. It will, if we want to change the gravity, if we want to analyze the gravitational force, analyze the result of gravity on this surface, we will select this one and we will click OK. Then we will run the next analysis. So if we want to add customized gravity, we can change this here, right here, and if we want to change the direction, we can change the direction right here. So as you can see here, it is taking the top plane as a reference geometry right here. So this is all about gravity. If we want to determine, or if we want to analyze gravitational structure analysis, this will be the method. And then the next one is centrifugal force. So centrifugal force applies an angular velocity and acceleration to a part or assembly. If we click on centrifugal force right here, as we know, centrifugal force is angular velocity and acceleration. So it is normally used in assemblies to run structure analysis on assemblies. So we are not talking about assemblies right here. We will so when we will talk about assemblies, we will talk about centrifugal force a little bit more. So let's cross it. Then what we have next? So the next we have right here is bearing load. Bearing loads are defined between contacting cylindrical faces. So when we are talking about two cylindrical faces, then this bearing load will be applied. Here we can see, here we have two options, selected entities. We can say this is not a cylindrical force, a cylindrical entity. So this bearing load cannot be applied to this model right here. So what we have next? is remote load or mass. So what is remote load or mass? Remote loads apply loads that would normally be transferred by connecting structure. So as per we say from this centrifugal force right here, from centrifugal force to bearing load, remote mass, distributed mass etc, to analyze this certain load advisor, we will need assemblies. In part file, these are this has no use. So if we want to use this, we will obviously need a part file assembly. So for this time, as we are not talking about assemblies, so we will ignore them, and when we will talk about assemblies, we will know how they work and in which way they works. And then next we have temperature. If we want to if we want to run temperature analysis, we will apply this temp right here. And as you can see, if we want to apply certain temperature on this phase right here, we will select this phase and we will give temperature, amount of temperature we want to. You can change the unit of temperature also. So this is all about temperature. So let's close it. And then we have flow effect. If we want to run fluid simulation, we will use this right here, this option right here. As we have selected static analysis only, so the fluid simulation is not possible. We will need to change this from static to dynamic. Solidworks. So we will learn about this later. No problem. For now, let's move to next sequence. So we will apply force on this. We have fixed this geometry. Now we will apply force on this face right here. On this face right here. So let's go to external advisor, click on force. So we will select this surface right here. So it's showing that it's the force has been applied in this direction. We want to reverse the direction, so we will click reverse the direction, and we will give a certain amount of, let's say 11,000 Newton, and then we will click OK. So as you can see, the force has been applied. So the force has been applied here. So this is it for now. We will discuss the next step in the next tutorial. It's showing us we need to save the document. We will click on save document. The save document will be saved. So this is it, guys. We will talk about the later parts in next classes. Thank you.